When I took a computer science class, my teacher said that programmers can be wrong, but computers can't. Well, sometimes they can be. Here's how. Computers store complex data with only two possibilities, on and off, or ones and zeros respectively. These ones and zeros are stored by bits. Computers use binary, a base 2 counting system, meaning that ones and zeros of those bits are actually representing powers of 2. The first bit is 2 to the power of 0, the second bit is 2 to the power of 1, etc. What tells these bits to flip from a 1 to a 0 is called a transistor. In order for computers to be wrong, there would have to be something that causes errors in this data storage system. That's where cosmic rays come in. Cosmic rays, despite being called rays, are high-energy atom fragments that come from space. When they hit Earth's atmosphere, they collide with the atoms there, causing showers of subatomic particles to rain down onto Earth's surface. One of the subatomic particles in these showers is radioactive neutrons. These neutrons are not affected by matter, so as they fly through the atmosphere, they pass through solid objects at about 1 per cubic centimeter per second. Since these neutrons are radioactive, when they pass through a computer's transistor, they can interact with the atoms inside of it and cause the transistor to gain or lose a charge, a process called ionization. So, these transistors, given a new charge, flip their bit, causing the memory stored in that bit to be wrong. You might be thinking, okay, what's the big deal? How does this actually affect anything? For the most part, it doesn't. Bit flips are often unnoticeable or minor inconveniences, but sometimes they can have significant effects. In 2003, Belgium tried out a new electronic voting system. At the end of the day, a communist candidate had more votes than there were voters in that district. After a recount, it was determined that the candidate had gotten exactly 4,096 extra votes. What's significant about this number? 4,096 is 2 to the power of 12, meaning that the 13th bit in a group was flipped. In 2008, a flight nosedived due to a bit flip in its angle of attack system. And in 2010, Toyota had to recall over 400,000 hybrid vehicles due to bit flips. So why isn't this talked about more? Why isn't it common knowledge that your safety is at the mercy of bit flips every time you board a plane or drive an electric car? Well, that's because in the past few years, manufacturers have started duplicating the computers in important machines like planes and cars, all but eliminating the risk of bit flips causing dangerous malfunctions. In conclusion, next time your router randomly goes out or your phone starts glitching, you'll know that you have cosmic rays to thank for that.